Today we are going to see the topic of partition coefficient. Introduction. If an excess amount of liquid or solid is added to a mixture of two immiscible liquid, it will distribute itself between the two phases so that each becomes saturated. If the substance is added to the immiscible solvents in an amount insufficient to saturate the solution, it will still become distributed between the two layers in a definite concentration ratio. These are the diagram of distributions. That is the solution of this is a separating funnel. That is the solution of X in water, and it is the ether. That is the organic layer. That is the aqueous layer. The soluble in inner, it is a molecule of X molecules are in less soluble in water. The partition coefficient is defined as the ratio of concentration of a compound in a mixture of two immiscible phases at equilibrium, a biphase of liquid phase, specifically for unionized solutes, in the logarithm of ratio of those log P. Hence, the partition coefficient measures how hydrophilic, I mean water loving, or hydrophobic, water fearing, chemical substances. This is the separating funnel. In above there is two layers. That is in above there is a organic layer is present. In another layer is a aqueous layer is present. When one of the solvents is water, the other is non-polar solvent. The log P values measures of lipophilicity or hydrophilicity. By another meaning, if C1 and C2 are the equilibrium concentration of the substance in solvent 1 and solvent 2, the equilibrium expression becomes K equal to C1 divided by C2. The equilibrium constant is K is known as the distribution ratio and distribution coefficient or partition coefficient. For example, when boric acid is distributed between water and amyl alcohol at a 25 degrees Celsius, the concentration in water is found to be 0.0510 mole per liter. In amyl alcohol, it is found to be 0.0155 mole per liter. So the value of partition coefficient is divided equal to the greater value of greater value of Pz for the partition coefficient of the drug, meaning higher lipid solubility, while if value partition coefficient is small, then that means of the drug has greater solubility in water more than in non-polar solvents. Importance of partition coefficient to the pharmacist. The preservation of oil and water system is important in preservation field for oil and water system. The solute can exist partially or wholly as associated molecule in one phase, or it may dissociate into ions in either of the liquid phases. However, in some cases of instance, benzoic acid can distribute it between oil phase and water phase, so it is used as a preservative when it is neither associated in oil phase or nor dissociated in aqueous phase. And then absorption and distribution of drug through the body. In the extraction process to remove the particular solute from homogeneous system by adding another solvent that is immiscible with the first one. In dosage form of formulation. Now we are going to see the determination of partition coefficient of benzoic acid between benzene and water. This is the calculations of partition coefficient. My students are explained in case study format for the determination of partition coefficient of benzene and water.
Today we are going to see about the determination of partition coefficient of benzoic acid between the water and benzene. In this experiment there are three samples, 250 mg, 500 mg and 750 mg. Now we are going to see the procedure of 750 mg sample. Weigh the sample of benzoic acid of 7.5 grams. The 7.5 grams of benzoic acid in the iodine flask. Take 50 ml of benzene in the measuring cylinder or 50 ml of benzene in the iodine flask. Take 50 ml of water in the measuring cylinder and pour it into the iodine flask. Keep the flask in constant temperature, shake well vigorously for 30 minutes. After 30 minutes, transfer the substance to a separating funnel to allow them to separate into two layers. The upper layer is aqueous layer, the down layer is organic layer. Transfer the 0.19 NaOH to the burette. After separation, we are separating the organic layer and aqueous layer. We have separated the organic layer, then take 10 ml of organic layer and put into the conical flask. Pour few drops of phenolphthalein. Titrate 10 ml with 0.1 n NaOH solution. At the end point, we got the pale pink color. Now taking the aqueous solution in the beaker. Aqueous solution, we are taking 0.01 n NaOH in the beaker. Take 10 ml of solution in the measuring cylinder and transfer into the conical flask. Few drops of phenolphthalein in the solution. Titrate 10 ml with 0.01 n NaOH solution. Calculate the distribution coefficient of benzoic acid between benzene and water.